This is Radio TV Phono Nut, and what we have here today is most likely one of the smallest stereo integrated tube amplifiers that was ever made, and also one of the cheapest and lowest end. This is a Trutest Stereo 8, and we have controls for off-on tone, stereo mono, a phono tuner selector, volume left and volume right. And on the back we have our left and right speaker connectors, a ground connection, and inputs for a tuner or ceramic phono cartridge. Here we are all opened up. This is just a 4-tube job with a 35W4 rectifier and a 35C5 output tube for each channel, and a 12AX7 dual triode for the driver stage. These were very cheap when new. In fact, there was a lower end version, I should say, that only had a tone high-low switch, and I found an ad for one of those. It was $9.95, and with this one having an actual potentiometer, it was probably about, $12.95, $14.95, something like that maybe. And these were sold through places like Lafayette, Allied, Olson Electronics, Radio Shack, etc., etc., under different brands, and they were all made in Japan. Now, what makes these types of amps particularly dangerous, and something like this would not be allowed to be manufactured today, is the fact that this does not use a transformer. It does not use a power transformer, so you have no isolation from the AC power line. In fact, the only thing isolating the power line from the actual chassis and signal ground back here is a capacitor, probably a 0.047 microfarad. Now, due to capacitive reactance, that capacitor is supposed to limit the amount of current that can flow down to a non-lethal level, but under the right conditions you can still get the crap knocked out of you by one of these, and you can damage other equipment plugged into it. And another problem is when this isolation capacitor becomes 50 years old, it's also likely going to be very leaky, which is also going to greaten the possibilities of you receiving a lethal shock or your equipment plugged into it getting damaged. Now, back then, all they really figured on you plugging into this was a record player attachment, and usually those didn't have any kind of a electrical connection between the actual signal ground and the AC line, so those were okay. And there were some cheap tuners that were designed to plug into this, but really the best way to operate one of these is to plug it into an isolation transformer. However, I think what we're going to do is replace the non-polarized power cord here with a polarized power cord and rewire the switch so it will be in the hot side of the power line. Because if we leave the switch in the neutral side of the power line, the chassis is going to be hot one way or another, depending on whether or not the unit is switched on or not. You know, whenever the unit's switched off, you've got to pass through the series string tube filaments to ground, and that can give you a hot chassis. And when the unit is turned on, depending on which way the plug is inserted, that can give you a hot chassis too. So the best thing to do is just use a polarized power cord, wire the switch in the hot side of the line, and replace that so-called isolation capacitor with a modern AC safety capacitor. Now, of course, rewiring the power plug won't do one bit of good if you happen to plug this into an outlet that's wired wrong, and apparently there's a lot of them that are that way. So just to play it safe, it'd be best to plug this into an isolation transformer. And that gray thing you see right there, that is the 0.05 microfarad chassis isolation cap, also known as the death cap. When I replace it, I'll replace it with a 0.015, which is the maximum allowable in today's world in this type of application for a piece of equipment to receive UL approval. A nice thing about this amp, most of the other capacitors are ceramic disc. Here's a closer look at the sloppy filter capacitor replacement. I just don't like that at all. If I can lay my hands on them, I think I have some fairly new manufactured multi-section electrolytic capacitors that were made for 5-tube radio repair. In fact, you can still buy those from Antique Electronics Supply. They're kind of pricey, but I wound up with a few of them that was in some junk that I obtained, so if I can lay my hands on one of those, I may just stick one of those in here and be done with it. And next, I think we'll spray our controls with this contact cleaner. Hopefully I won't have to replace any of these pots. I know in the past I've had trouble with these cheap Japanese potentiometers, but if I have to replace them, there's not really anything exotic here. I should be able to source replacements easy enough. Alright, I cleaned it up a bit. 3 of the 4 tubes are Toshiba originals. The rectifier is a RCA replacement. You can see it's kind of rusty in spots, and I think that's from the probably condensation, because this thing gets very hot. 3 of these 4 tubes get extremely hot, and in this small metal enclosure, that's a lot of heat built up, and during the heating up and cooling down, some degree of condensation is going to form, and over time that will cause rust. And I cleaned the front panel up a bit. Here's the cage. I cleaned it up a little bit. It looks pretty good, except for one little spot of rust on the top there. I could sand that and patch that with some gold paint. May do that later, but I'm not worried about that right now. And looking at this power plug, you can see where somebody already marked one side of it with a piece of duct tape. So that tells me that somebody already got the crap knocked out of them by this thing at some point, so they marked the plug to know which way to insert it in the outlet and not get the crap knocked out of them. Alright, it looks like our hot side of the plug is what's marked here. Alright, it's playing, but as you can tell, we have ground loop hum like crazy.
By the time I get to Phoenix, she'll be right. One is the loneliest.
Okay, enough of that. And another thing I discovered is this power switch is stuck in the on position. Probably happened from a electrical mishap, and it got welded in the on position. Now here are the speakers that we're using with this, some that I picked up at an estate sale this morning. I didn't really want them. I wanted the receiver that was connected to them, but he didn't want to sell them separately, so I bought the whole thing. Get off of there. This looks like some white van special. And really, I'm surprised they're doing as good on this little amp as they are, because generally these kind of speakers require a lot of wattage to push them to decent volume levels. But, you know, I can pair them with a little receiver and put a turntable with it, and it'll make somebody a good starter system. But for right now, we're using them to test out this amplifier. Well, I can't put my hands on those multi-section capacitors that I have, so I'm just going to do it with regular capacitors. And I'm looking at this mess that somebody made. We have 3 capacitors here. this biggest capacitor is in parallel with this tubular capacitor down here. And it looks like I see another small electrolytic down there. That's probably for the cathode bypass for the audio output tubes. I have no idea what the original values were, but I can make a educated guess. I'm going to go as high as I can without putting something in there too big that might cause a excessive surge on the rectifier tube, because since this is audio, I'm going to try to filter it as best I can to reduce as much background hum as possible. Now that ground loop hum we heard, that's nothing to do with the filter capacitor. That has to do with this being a line operated amplifier and it not being happy with the CD player I had plugged into it. And when they soldered this on, thankfully they didn't do a very good job, because all I had to do was touch the soldering iron to the solder and the wires just separated, which tells me no mechanical connection was made. Now, why did I say thankfully? Because it's making it easier to take apart this mess. Alright, here's the mess removed. Looks like they used some no-name cheapo crap. We have a 68 microfarad that they had in parallel with a 40. And then we have a 33 and a 22 here. Okay, I went ahead and cut the old power cord out since we're going to be replacing it with a polarized cord and rewiring the switch. Now, as far as this switch that's stuck in the on position, and I've already checked, this extra terminal is not going to do us any good, as in I can't move my wire over here and have a good portion of a switch we can use. But anyway, since I'm going to have to rewire the switch, and if I can't find a suitable ganged pot with a switch on the back of it, I may just have to wire an inline switch in the power cord. But as far as our filter cap replacement, here's the terminal strip I want to use, and it has the precise number of terminals on it that I need. It would be easier to mount it right here, but then our capacitors are going to be close to this hot rectifier tube, and we may have to do that, but I really don't want to do that. I would rather mount it down here, but then we may not have room for the capacitors, so we'll just have to see. Losing things left and right. Now let me spend 30 minutes digging in the black hole and try to find that terminal strip. Okay, there's the terminal strip soldered to the chassis. Of course, we had to sand the chassis down to get the coating off of it so solder would stick to it. And we have our appropriate wires connected to the terminal strip there. So now all we got to do is mount the capacitors. Okay, I found a schematic online on YouTube, as a matter of fact. And the schematic online calls for 50 microfarad, 30 microfarad, 22 microfarad. Well, I'm kind of running low on caps, so I'm going with a 68, a 33, and a 22. And the main reason I'm not going with the 100 that I had out earlier is because of size. We need these things to be as small as possible to fit in the allotted space, and since that's what was in this from the factory, it ought to do okay. I mean, after all, this is not no ultra high fidelity musical reproducing amplifier here. This is a low-end amplifier. Okay, we have our filter capacitors in place. I have the switch rewired to be in the hot side of the line, and I'm about to install the power cord, and our switch has started to behave. I guess all that cleaner I sprayed in it freed it up, so let's just hope it stays that way. Here's our power cord salvaged off of a junk DVD player. It's one of the double insulated types. Yeah, Chinese electronics are good for one thing. They usually have usable power cords. Now our hot side is the narrow blade, and that corresponds to the black lead here. Our neutral side is the wide blade, and it corresponds to the white lead here, and you can also see there's a white band on the outer jacket of the power cord. We have our off-on switch rewired to be in the hot side, so we'll connect the black wire to the switch, and then we'll connect the neutral wire, which is the white wire to our circuit ground, which the negative tie point for the filter capacitors is a convenient location for that. Here's the death cap. It's a Lilly brand, 0.05 at 600 volts. Now, I still haven't repaired my old school Heathkit capacitor tester, so let's try another crude way of seeing if this thing is leaky. Here's a brand spanking new 9-volt battery. You can see it's putting out 10 volts with no load. Let's put the capacitor in series with the battery and see if we get any DC voltage. If this capacitor is good, then there shouldn't be any DC on the other side of it. Alright, we're getting 0.05, 0.04 now, which is not as bad as it could be, but there should be nothing there. Here's the new capacitor, and I'm getting absolutely 0, which is what I expect. Just for fun, here's 3 9-volt batteries in series to give us 30 volts. Let me move this to a lower scale. Hang on. Here we are on a lower scale, and you see how long it's taking it to drop. That's because that capacitor is leaky. And yes, it would probably pose a safety threat. And the battery's running very low, so let me get this new safety capacitor in and then go from there. Alright, there's the death capacitor replaced. I don't like doing them that way, but this one had a little short, stubby leads for printed circuit board mounting, so I had no choice but to do it this way. Alright, I have it plugged in, not plugged in, but attached to my ohm meter. Turn it on, and we're getting resistance across the tube string. From neutral to chassis, I'm not getting anything. That's good. And from hot to chassis, I'm not getting any resistance. So that's what we want. I have my voltmeter set to AC. Have one lead of my voltmeter connected to earth ground. The other end connected to chassis with the instrument off. And I'm getting 122 volts AC. Turn it on, and I'm still getting 122 volts AC. Why is that? Well, I'll tell you why. Because when my father built this workshop years ago, he wired it wrong. I think he thought black meant neutral or negative. I've just should have corrected it, but I've just always been careful all these years. So the point I was trying to illustrate with that was, even though we replaced the power cord with a polarized cord and wired the hot side into the switch, you plug it into an outlet that's wired wrong, and there's going to be problems. And we also demonstrated that this capacitor is not going to keep 120 volts off the case of the amplifier. What that capacitor is going to do by means of capacitive reactance is hopefully keep the current level low enough that you won't get electrocuted. However, if you touch this chassis while touching something with a return path to ground and you have this thing plugged into a miswired outlet, you will know that you grabbed a hold of something. So that's why I say, either make sure your outlet is wired correctly. You know, they make outlet testers for that. If you don't know how to interpret voltmeter readings, or plug this thing into a separate isolation transformer. You see, I'm getting 122 volts when measuring between what's supposed to be the neutral and earth ground. Now when I measure between what's supposed to be hot and earth ground, I get nothing. Now let's move to an outlet that is wired correctly. Here's an outlet that is wired correctly. I had the meter connected to a known earth ground. Between a known earth ground and the narrow blade hot, I'm getting 123 volts. That's what we're supposed to get. And between earth ground and neutral, I'm getting 0. Here's the amplifier connected between chassis and earth ground, as you can see, and I'm getting nothing. Turn it on, and I'm still getting nothing. So this chassis is safe whenever it's plugged into a correctly wired outlet. Okay, we're back on the amplifier, and like I've already stated, I replaced the power cord one with a polarized one and moved the line switch to the hot side of the line. This little wrap of tape on the power cord is to keep somebody from pulling it out the back of the amplifier, since I don't have any strain relieves handy. There was no grommet where the power cord enters this portion of the chassis, so I put one there just for protection. Clean the pots, clean the tube sockets, clean the tubes up. They're not as grungy looking. Replace the death cap. And I did something that I probably didn't need to do. It was probably unnecessary, but I did it anyway. Some of the disc capacitors looked kind of baked, and some of them actually had cracks in them, so I went ahead and replaced all of them with film capacitors. You know, that should make the audiophiles happy, since they claim that film capacitors do better for audio than ceramic discs do. And as you can see, in some cases I used orange drop capacitors because, number one, I had them on hand, and number two, the leads on them are a lot longer than the typical Panasonic or Nichicon capacitors that you buy. And it really looks a lot better than it did before. And these components, these capacitors, are better quality than the originals. I checked all of the resistors, and every one of them are well within tolerance, so we're going to leave those alone. Alright, with all that said, I think we can go fire it up and see what it sounds like. And here we are turned on, and I'm greeted with this crap, 60 cycle hum. So I wonder what that could be. Well, I've looked over everything, and I made a continuity check on my ground line, and that's good. Did the same thing on the B+ lines coming off of the capacitors, and all those are good. So I don't know why we have the 60 cycle hum. Maybe we've either got a heater to cathode short in a tube, or one of these filter capacitors is bad, brand new ones. And I'll tell you something else, if I had a speaker terminal quick connect strip handy, I'd replace this screw terminal strip with a quick connect, and that way I could just swap out the speakers and disconnect my speakers and all that without having to unscrew the terminals here. You know, for a permanent installation, screw terminals are not too bad, but when you're testing something, or there's a possibility you might be moving something from one location to another, it helps to have quick connect spring-loaded speaker terminals. Okay, the tube's checked fine. I rechecked all my connections. I reflowed a couple of connections on a terminal strip down here that happened to involve the ground line, and reflowed my own connections just to be sure. Now let's go try it one more time. Well, did we get rid of the hum? Well, we got rid of the 60 cycle hum by reflowing those connections. But however, which I figured we'd still have it, we still had this pesky ground loop hum. And that's not going to get it. And that's all because this older equipment doesn't really like this newer equipment. So we're going to have to come up with a ground loop isolator, or run this off of an isolation transformer, something to do away with that, because we can't have that. And by the way, these speakers are a pair of realistic Minimus 7s that I picked up at a church rummage sale for a little of nothing. They're kind of dinged up, but for what I paid for them, we ain't worried about that. Okay, I tried plugging the amp into an isolation transformer, still no change. I tried reversing the plug on both the amp and the DVD player, no change there. So the only thing I know to try is a ground loop isolator on the input and see if that'll do it, which I don't have one here. Maybe I can try to fabricate something. But yeah, these older amps like this were not made to be used with this newer equipment. They were made to be used mainly with record changers that have no type of electrical connection between the cartridge ground and the AC line. Here's an Olson AM/FM solid state stereo tuner, probably from the mid-60s. And Olson was another one of those supply houses like Lafayette and Allied. And yes, we have the standard Social Security number or some kind of ID number engraved in the front of it. That used to be common practice back then, and frankly, if I were going to engrave an ID number of some type on my equipment, it would be in a spot not so prominent, but whatever. I don't even know if this works or not, but I thought we could try it as a signal source and see what it does through that amplifier. It's Japanese built, but it looks like it's a well-built tuner, and I see where they were thoughtful enough to put service panels on the bottom of the case that you can remove to access the foil side of the circuit board. Here's the inside. It looks to be a decent made set. And I'm getting the same crap with this tuner.
How much weather affects your bill depends on...
See if FM does anything. FM appears to be pretty weak. AM's not far behind. So this tuner's going to need some help, but that'll be for another video. See, if I unplug the signal source, it's pretty much quiet, even all the way up. All I'm getting is minimal noise. Plug in a signal source, it starts humming like a son of a gun. Now, I dug out this old BSR record changer. I think the needle's about shot in it, but it's good enough for testing purposes. And as you can hear, no ground loop hum.
God, that is our Father, the blessed angels came unto...
Okay, there's really not much more I can do to this. I have a ground loop isolator ordered off of eBay. You know, back in the day, I could just run around a Radio Shack and get one, but there's no such place left anymore. Virtually anything I need now, I have to order it. So when that gets here, maybe we can play this thing on tuners and CD players and whatnot and not have an annoying ground loop hum. Maybe we can actually use this for something other than record changers. Okay, this is a long shot, and I really don't think this is going to work, but as they say, nothing ventured, nothing gained. Originally, they had the signal grounds for our inputs here connected to the chassis, and then of course there's the capacitor between the chassis and actual circuit ground. Well, I lifted the negative lead from our signal inputs from the chassis, and I have a .0047 capacitor connected between the ground of these signal jacks to chassis, and I'm going to see if that does anything. Like I said, I really don't look for it to, but you know, it's worth a try anyway. Well, devil know it didn't help. I'm about ready to throw this hunk of crap in the garbage. Okay, we have the amp plugged into the isolation transformer, and I have the depth cap bypassed. In other words, this is very dangerous now. It's a for real hot chassis, and it would not be safe to plug this in directly to the wall. So let's get the remote and fire this DVD player up and see if we still have the hum. How about that? Alright, let's see what happens when I put the depth cap back in circuit. Yep, just what I thought. Okay, so there's really only two ways to use this in a practical way. Bypass this depth capacitor and run the amp through an isolation transformer, because even though we have our AC cord rewired, if this was plugged into a miswired outlet and this chassis was hot, that would not be a good combination. So bypass the depth capacitor, make this whole thing circuit ground, connect the amp through an isolation transformer and play anything you want to through it. Or possibly connect a ground loop isolator to your inputs, and we won't know for definite if that'll work until the one I ordered shows up in the mail. But for right now, I've done about all I can do with this. I'm putting it back together. Maybe when I get the ground loop isolator in, I'll do a test on it, and I'll throw in the test as a part of another video. But that's about all I've got on this one for now.